We're on here on Strictly Based episode 2, and here as
I'm Dean, and so we're sitting with, go ahead and introduce
John Scott. I'm a chemist at the Illinois Sustainable Technology Center.
Mhm.
We're part of the Prairie Research Institute at the University of Illinois. That's a mouthful.
nice to meet you.
Nice to meet you.
Yeah, nice to meet you guys.
So, if you want to give a quick background of what your research is in.
Sure. So I'm very interested in pollution, and I spent many years doing inorganic stuff, like looking at arsenic in the aquifers. And then I moved into organics. I looked at things like PCBs, pesticides, and I tracked them in the environment. And now really my focus is what we call emerging contaminants, which are contaminants that are not regulated, but that we're finding in the environment. And we really don't know what the negative, if there's any negative ecosystem impacts associated with them, or if there's any negative human health effects. There's over 1 million new chemicals developed every year, and you just imagine these things are finding their way into markets and in the environment. And it's really a wide breadth of things that we're chasing after.
A lot of the things that you mentioned, especially like before, like the new chemicals that you mentioned, where a lot of those end up being runoff, right? Like they end up leaching into like our water systems, they end up being usually part of the water system. That's like, correct me if I'm wrong, but that's usually the most common way of contamination, right?
Yeah, it's a good transport mechanism for them. That's how they move through soil. That's how they get exposed to people when they drink the water. And then when we use them to irrigate our fields, they get taken up by plants. And even air deposition and wet deposition, these things will volatilize and then be redistributed. They might move, and then rain down in another area. So yeah, it is a good way to transport contaminants is through water.
And I was reading one of your articles from 2021, and you mentioned that microplastics are in everything. And you're actually surprised if you examine something and didn't find microplastics.
That's correct.
So I was speaking to like one of my buddies because he argues about organic food and says, like, regardless of the apple you're going to buy, the apple will have microplastics.
That's right.
And I couldn't really wrap my head around how does that totally work out. Is that for like irrigation? Is that through farming?
Yeah, and even air deposition, microplastics raining plastic in some regards.
Interesting.
And it's because we surround ourselves with these materials. And if you look at how much we produce every year, it's a staggering amount. And it's just getting more and more and more every year. I think it was, 550 million metric tons per year? And then if we project that out to 2050 in this business as usual model, every year we'll be making 1.8 billion metric tons of plastic. It's a staggering amount of material. Here's an interesting thing: as a colleague of mine, Tim Holine, who's at Loyola University, he obtained some fish from the Field Museum that went back, decades to the 1900s. And even he could start to see, as soon as plastic came onto the market, he started to see it in the wildlife. So he believes that, and I believe him, that it's a function of how much we're making. So the more and more and more and more we're going to make of it, the more and more and more we're going to see of it in the environment.
So is the concentration of, because you mentioned in the rain, but also just like in basically everything, right?
In the air we're breathing right now.
There you go. So is that more of a result of like plastic waste, or is that just because plastic is literally everywhere? So if I'm wearing like an acrylic like sweater, right?
That's a source.
So that's like, it's just kind of, it's getting, like if I'm using like a plastic bottle, you could say like the plastics are like leaching into like
the water.
Just the water itself too?
The water itself too, yeah. In fact, every time you open up that cap and you close that cap, you're making little pieces of plastic, some that are nanoplastics even, that'll get into the water. And a lot of it's there too from the manufacturing of the water. Making it, it comes in contact with plastic parts and gets into the water as well.
Is there a hierarchy of, I guess, harm of plastic, right? So there's like, we talk about BPA free, we talk about this and that. Like, what is there like a truly harmful and a harmless plastic, or are they all just kind of disrupting something in some way?
Nobody knows the answer for sure, but one thing that's important is the size. So as these things get smaller and smaller, they have a higher potential to cross biological membranes.
Interesting.
They're more mobile in the environment, and they're much more difficult to remediate. So the other thing is, when we talk about the toxicity of plastic, the other thing is plastics are extremely complex materials. In fact, we know that we use over 10,000 different chemicals in the manufacturing of plastics as additives. And a recent study found that 25% of those are known to be toxic, to be carcinogenic, to be persistent, endocrine disrupting, all those things. But the thing is, if you put them in a plastic, certain materials are allowed to put these things in. You can put lead in a plastic because it's not intended for human consumption. But when it gets in the environment and it becomes mobile, then it could potentially end up in someone's drinking water, end up in an animal, be breathed by a human being. So, but back to your question, it is we're surrounding ourselves with it. But the other thing too is we're accumulating so much of this waste. I mean, think about our landfills just must be swelling with this material.
Yeah.
It's really not going to go anywhere.
Yeah. Okay. Is there like a compounding effect too? Similar, like I know, like with mercury in fish, it kind of climbs up the food chain.
Yes.
Right? So is there a similar compounding effect where it's like each
biomagnification?
That's the word. Yeah.
Yeah, and there are studies that are suggesting that plastics do biomagnify.
Okay.
I don't do that type of work, but I have seen more and more papers that suggest that's the case.
I see. Okay. Interesting.
Moving on to another section.
I'm just checking the camera real quick while you're talking.
Yeah. Moving on to another section I was pretty interested in. And I looked at your PFAS, and I know how they're referred as forever chemicals.
Yes.
Could you give us like a little insight on why we refer to them as forever chemicals, and any other added benefits?
The things that make these things so useful is what also makes them so problematic. So they made them when they started around the 50s, I believe, the 60s, and because they had a lot of nice properties, like they're oil and water resistant, yet they're highly water soluble, which makes that a problem too. So if something's highly water soluble, you can get a lot of it dissolved in the water. But the thing that's really problematic about them is these carbon fluorine bonds that they have. They are some of the strongest chemical bonds known to man. So that's why they're just so darn difficult to break down. We can break it down. That's easy. The problem is we can't do it in a cost-effective way. It takes a lot of energy.
And you need to usually add in like external sources, like external chemicals, in order to break that down further, right?
Yeah, so a lot of times bases, solvents, a lot of temperature, a lot of heat. And the other thing is you have to be careful of. The goal of PFAS remediation is what we call mineralization. So we want to break it down all the way to the fluoride ion. But a lot of technologies, they don't really break it down to fluoride ion. They just break down the PFOA, but they might be creating a different type of PFAS that's smaller, more toxic, more mobile. So really the goal when we do that is to break those carbon fluorine bonds.
And if you don't end up doing that, you could cause a bigger problem.
Yes.
Yeah. Okay, interesting. Okay, and then that's of course like why it's not biodegradable and things like that.
Nature hasn't figured out a way to bust those carbon fluorine bonds.
Okay.
Very, very strong. And it's crazy that we've made these chemicals, and a lot of them were intended to only be used for a short amount of time. And the same thing with plastic, right?
Disposable, yeah.
Yeah, it's intended to be used for a couple minutes, but made to live forever. It's a terrible system.
It's weird, right?
Terrible system.
Yeah.
And do you see that, like, in our future direction of, obviously we have to combat like what's happening now? Have you ever considered, what's a possibility in 2050 if we don't try to combat this? What could affect us as a population?
So I think if I understand it correctly, if we don't do anything, let it go as business as usual.
Business as usual.
Yeah. What's going to happen? Well, certainly there's going to be some economic impact to that, right? I mean, if you can't eat fish anymore out of the ocean because there's more plastic than fish in the ocean by 2050 is what they're projecting. There's going to have some economic implications. And for food scarcity. You could potentially start seeing more illness, more disease related to these things. I honestly don't think it's going to happen. I think we're going to figure it out. I'm an optimist, though. And the thing about plastic is you'll never completely eradicate it. You shouldn't. If I put a pacemaker in your heart, you're going to want it
to like be absorbed.
I mean, but the thing is you want it to be plastic, and that's a good place for it. I mean, it's going to be there for a long time,
right?
But there is certain things that we could probably do well without, like plastic straws, plastic utensils, plastic cups.
Well, what do you see as like the most, I guess, like the highest potential solution? So we've all seen like biodegradable things. We've all seen like natural, like vegetable-based plastics, things like that. What do you see as the most likely or the most, I guess, approachable solution?
There's not one. And if I can use that board, are you guys familiar with the pollution prevention hierarchy?
Sure. I mean,
May
go
I?
ahead. Yeah.
Okay, let me show you something. I believe that we need to tackle it at all stages of this pollution prevention hierarchy. So the first stage is called reduction, or we can call it new materials as well. And what happens in this area is, first of all, we get people to use less, right? We identify what we can get rid of, and then we can use less. And then materials replacement, that's where we can develop new materials that don't have as much environmental impact. Right?
Okay.
That's one stage. The other stage, we can tackle it. Now, as you go, this is the most preferred. Okay? Most preferred, and I'm a terrible speller. Spell check did that to me, and I'm sure it's done it to you guys too. But anyhow, the second stage is reuse, right? We can find innovative ways to reuse materials multiple times. You know, glass is a great example. The only problem is it's heavy, and if we want all the bottles went from plastic to glass, then we might be creating a CO2 problem just from transporting it and moving it around. So we have to think about all these other things too. But reuse, and then here's another area that we can really do a better job in is recycle. Right? Right now we're only recycling about 8% of all the plastic, but I think that there can be some really good innovation in this area.
Okay.
Because it's really important, because people know recycling. We've already, behavior change is one of the most difficult things to do, but people have already been trained to recycle.
Yeah.
So if we can do a better job of making that number higher, then we have the potential to reduce the amount of plastic that we're making.
With recycling though, isn't there like a, it's almost like you're kicking the issue down like a step, right?
You are.
Yeah, so you can only recycle something so many times, correct?
That's true.
And then at the same time too, it depends on the use, right? It depends on how disposable it's going to be.
That's right.
So, okay, so with recycling, how, let's say we're going to do 100% recycling, we're just elongating the lifetime of the plastic.
You're right.
But are we necessarily like...
But we're reducing the amount that we need to make in the first place.
Okay, right? That makes a lot of sense.
And I'm not saying that this is the end all be all, but my point is that we can tackle it at all these stages.
We can make the life cycle more circular.
Yeah, and I think we really need to stimulate all these. And there's even more. There's another one that we are involved in too, and it's energy recovery.
Yeah.
And I'm not a big fan of that, because you're basically just burning it or creating into a fuel and then putting it in the atmosphere. But you got to remember that we are sitting on something like how many billions of metric tons of plastic waste? It's not going anywhere. Even if we quit plastic cold turkey tomorrow, we still have all those billions of metric tons of waste to deal with, and that could be a potentially way to deal with it.
And that's incineration and things like that.
Well, there's also a lot of plastics are made from petroleum products, and in our lab, for certain plastics, we can actually depolymerize it and turn it into a fuel-like material. You can also use it for aviation fuel. If it's done right, you can use it as additives.
Okay.
So, but it's not the most preferred, but it's another approach.
I seen a guy on Instagram that has, he built a machine in his garage to create fuel out of just like plastic bottles and stuff.
Yeah.
Okay, interesting.
Yeah, but the problem with that system is additives too. That's one thing that really ruins this chain. I believe if
there needs to be an input.
Well, what happens in a lot of plastics, they add something to a plastic that makes it so it doesn't recycle well.
Okay.
Or it makes it so you can't really recover energy from it.
I see.
So if the manufacturers of plastics get together with people that are doing recycling, that are doing energy recovery, and they determine that, maybe we don't need this additive because downstream it affects how we can recycle it, how we can get energy from it, that there needs to be better communication between these groups, so and better coordination, Yeah. So like if you do you really need to make that plastic black? Can you just get away with having it being clear so we can recycle it better later or get energy from it?
Yeah.
The last thing's always treatment, and that's really what you don't want to do. But even that you have to entertain, because landfills, right?
It exists, like the problem is there.
Yeah, so eventually if we don't want these to get out of the landfills, we need to think about maybe treating them. That's not going to be very easy. It's very expensive.
Interesting.
I have a pretty unique question for you.
May I sit down?
Yeah, go ahead, yeah.
So if we were to speak about reintroducing, imagine plastic had just been made and you're in charge of introducing them into the environment. Because obviously plastics are needed in society. Wouldn't you say so?
Yeah, they are.
Okay, how could we have done it differently in a point where we wouldn't have this issue? Or if we do have this issue, it's not as scalable as it is currently.
Yeah. Well, I mean, putting better thought into how these things where they will end up in the environment and how we can make them better so they don't have so much environmental impact. But that's hard to do. I mean, it's hard to anticipate all the problems. It's a tough question.
Yeah.
You know, I think about chemicals. I'm trying to think how this would fit into that. But example, let's say you're a company that uses some chemicals, right?
Yeah.
And the way it works right now is that you go to some chemical company and you say, I need 500 gallons of this chemical, sell it to me. And they don't care. They actually want you to use more chemicals, right? Because they make more money. But what if you had a different system and instead of buying chemicals, you bought a chemical service? Okay. And what the company did is actually provide you with just what you needed to get what you needed out the door. And I've seen this done in certain organizations, so they actually would have a person from the chemical company working in the plant, finding ways for them to reduce their chemical use because it was incentive for them because they made more money. So it was like a chemical service, and you can do that with lots of things. They do it with floors. Instead of selling, you know, in fact, U of I did that. In fact, if you notice, the floors are, so now instead of replacing the whole floor, they have a floor service and they just come in and replace the one panel.
Yeah.
You could do that with a lot of things. It's going to a service-based model instead of a product-based model, I guess, if you will.
Yeah. And in some cases, that could be a win-win as well.
Exactly, that's the whole point. So, could you do something like that with plastic?
Yeah.
I don't know. I would be thinking about that up front. I mean,
well, you did mention, so like in terms of additives and things like that, are there, well, I'm sure there are, but like how accessible are plastics that are still durable, that still serve the functions they need, but have more sustainable components that are more easy to break down? Usually the issue is cost though, correct?
Yeah, it is cost, but also that's very difficult nut to crack. To have something that has the material, that has the properties like plastic, but breaks down right when you want it. People are working very hard on it. And I know that, you know, people are out there trying to do that material science. It's just not easy.
Okay.
So we're just hoping by like the next coming years, people will innovate and find us a way out of this mess.
Yeah, definitely. But I think the important thing is that people need to really think twice about the choices they make.
Yeah.
You know, I think that's important. That's really the goal, holy grail for us, is to move people away from these materials. Let them know how their choices impact the environment, themselves, and their fellow human beings. And so they'll think twice about it.
Yeah.
Like me personally, I used to drink from plastic water bottles a lot, and buy those cases, especially being in college. I don't know about the tap water. Exactly. I recently invested in a reverse osmosis filter, not only to stop buying those plastic water bottles, but to also filter out the plastic in my current tap water.
Yeah.
So, in terms of why I bought it, I looked into it. It was a lot based on human health perspective. And if you want to discuss about your research within plastics in water or food that affect human health in terms of the endocrine system, if you have any insight on that.
Yeah, well, I mean, like I said before, a lot of plastics have additives, but they're not supposed to be in there if it's intended for human exposure. Where was I going with this? I had a point. Plastics are usually, they will also absorb pollutants from the environment, so they kind of seem as a transport mechanism as well. I can't stop thinking about, you're talking about how you bought your RO system. You know, I live out in the country. I'm going to kind of deflect for a minute. I have trouble. But I live out in the country and I see everybody always buying cases of water bottles. It makes me sick. And I have a spreadsheet and I show them that if you buy this carafe, it's just a one plastic carafe, it's got a ceramic bottom, and you're going to save money. Because the money they're spending on those water bottles isn't it?
Yeah.
And so and then you know what? They all started to change.
Interesting.
Because when you put it in terms of economics, they don't care about human health really. A lot of people in my neighborhood, they got a lot of other things to worry about. But when you turn it into an economic thing, boom, you get people's attention.
Well, it's also like hard to observe the negative health outcomes too. So that's like like if you just put money into the equation, then it becomes a lot more tangible.
That's right.
So, yeah.
And that's something I've always been hungry for is to help. I need to find an economics guy who can help me show people.
Just put it all on the graph.
Yeah, that there's an economic impact, like tourism and beaches and the fishing industry. And the other thing too is I go to all these conferences. They're always well represented by the physical sciences guys. We have all kinds of good chemists, we have all kinds of good biologists working on this thing, but I rarely see a psychologist. I went to a meeting and I saw a woman psychologist, sociologist, or I can't remember which one, but she was giving a talk about behavior change and if she had people that participated in a cleanup, they would be less likely to litter themselves, or when people saw litter, they were more likely to litter. And I mean, these were really cool studies. And I really want to see more of that. I really want to engage more in the social sciences, get them involved, because they're a major piece of the problem, or the solution, not the problem.
Because like we said in the hierarchy, the first step of the solution was
behavior change.
Behavior,
I mean, I myself, I'm studying here at U of M, I'm studying sustainable design. So a lot of that, it's very multidisciplinary, right? So we talk about a little bit of architecture, urban planning, everything basically just to create a more sustainable future, and sustainable meaning something that if we make now can be used generations from now as well. So one of the biggest things is to not introduce something new, which you covered a lot. Which is like, if we can use buildings that were made 100 years ago, that's always going to be making a new sustainable building. Because there's no energy input that you're adding. Another thing, again, is behavior change, like you mentioned. That's one of the biggest things. And a lot of sustainable design around urban planning is all about community engagement. So it's about meeting people's needs while also balancing the economics, while also balancing the social, and then everything in between to make sure people are still making their money while they can have a better quality of life. So it's a hard balance to kind of maintain, and it's interesting to see how it plays out in different communities. And really, I'm coming on to my third year now, and it seems like every class is just kind of bring me towards the solution being, it just depends on where you're at.
That's right.
So it depends on who you're around, where you're at, and what these particular people need. So the solutions are really interesting because it just ends up being some level of like vernacular approach, right? It's, if this person has this problem, how else have they usually solved that problem? How can we adapt that into what we're dealing with now? But I guess to take it back to that's just like my own reflection on this concept. I found it interesting that it carries over the same type of concept. But in terms of like our own like health outcomes, have you observed anything with plastics, with the microplastics or anything like that? Have you observed anything with human health or animal health? Or what are the differences between the pre-plastics versus now? We're living in a, I guess, post-plastics world. What are the health outcomes? What's the what are we exactly damaging with these plastics?
Nobody knows that. That's still up for debate.
And is that because like plastics are still relatively new?
No, because it's really hard to expose organisms to environmentally relevant concentrations of these things and get actual measurable toxicity outcomes. I mean, if you feed PFAS, for example, you feed a rat a pound of that stuff, I guarantee it's going to get cancer. But the problem is if you give it like 5 parts per trillion, it's just so hard to and a lot of this, you got to remember, we got to really look at long-term exposure. How can you do a 20-year study? I mean, it's very difficult. I mean, who's going to fund that? I would love to get that funded for 20 years, talk about security, to study how, and I don't do toxicity, I don't kill rats in my lab. I'm more of a chemical side guy, but how do you determine that long-term?
And how do you create a control group for something like that too?
That's true, especially with something that's ubiquitous. That's pretty much everywhere anyways. It's very difficult. But that's where epidemiology comes in. And that's where, a lot of times you can go back and look at, with there's data out there, you can look at PFAS, for example. It was epidemiology studies that really showed that it's toxic. And because they were looking at people that worked at a chemical company that was making it, and then they started to find cancer, to test testicular cancer and certain liver cancers in the populations, and those people were being exposed to very high concentrations.
I see.
So hopefully that.
Hopefully
I have to look over my shoulder.
And I feel like that might also the idea of corporate interest that I feel like that also can kind of muddy the waters around this sort of thing. And I'm sure like there's like monumental cases with things like DuPont, right?
Yep.
It's a huge company where they ruined anyone's ability to even understand what the issue is that they're causing.
Yeah.
And of course they caused numerous cancers in multiple people, I'm sure.
Yeah.
Have you heard about this? I think they got like a Netflix.
Yeah, it's called Dirty Waters.
There you go.
Yeah, in fact, I know Rob Beloit. He's the lawyer that
okay.
movie's about. I sat on panels with him before.
That's insane.
Yeah,
Okay.
and he yells at me all the time because he goes, PFAS is not an emerging contaminant. It's been around since the 70s and we've known about it. So you're right. Yeah, they buried it.
It's and we find that a lot in terms of just general like health in general, and always because it's just motivated by profits usually.
Yeah.
Just like, okay, we can have this really cheap material, but now people are starting to find that there's something that we can do against that. We need to make sure that it's just something we can still profit from. So it's
going to come back to haunt them now.
Yeah.
Because now they're facing unprecedented fines, right? And I wondered if plastic is going to be a similar thing.
Yeah.
And if they think about it, they might be able to stop themselves from liability. These people same company making these large amounts of these plastics.
Yeah.
They might start, and I think they are. I think it's on the radar that we might need to start thinking about changing, because down the road this could turn out to be
definitely
millions of dollars in lawsuits.
Yeah.
A lot of times with like a lot of health studies, I often see corporations are funding these studies.
Oh yeah.
And
Classic like cereal being good for your health. The cereal's good,
Yeah.
like part of a good breakfast and stuff like
defeats
that.
the point, because now it's structured in a way where whatever the company wants ends up being the result.
That's true.
And with a lot of like research, if you look into statistics, a lot of times you can skew anything to your favor.
Yeah.
Like you can have and under 40 people, you could have like certain people are going to sway a certain way in this group. So it's all based on the researcher himself as well. He could dictate where this research ends up looking like at the end.
Have you ever experienced, you're a researcher yourself, have you seen, not to throw like colleagues under the bus or anything like that, but like, have you seen in the practice people kind of being swayed one way or another by...
Not in my field.
Okay.
Because we don't get much corporate private funds.
Interesting.
It's all dictated by who funds us
right
now. So a lot of the federal agencies fund our research, so we're
being more
restrictive.
restrictive.
Yeah.
Okay.
So I haven't seen it, but I know of numerous cases. Lead's another one. When lead was being put in gasoline, that was a major one. That was lobbied, and research came out from the industry that was contradictory to the geologist that was finding it everywhere. So I'm familiar with those cases, but we don't see that now. But that could change.
Yeah.
With the new administration coming, and if he cuts all of our federal funding, we may have to start
Got to source from other places.
We're already starting to think how that this is going to affect our research portfolio.
And I had a personal question for you. What future research are you most interested in looking into?
I can't tell you one. There's tons of stuff. In fact, I love my job. One of the things I love about it is it's always changing. This PFAS stuff how did you find out? How did you get in contact with me?
That was all you and...
We were just, because we were looking at UVI professors who, Microplastics, we also emailed a couple other professors, but you're the only one who reached out back to us.
So I appreciate that.
Yeah, I appreciate it.
Because like I said, I'm really big in outreach. Yeah. But it's constantly changing. Last week I just submitted a paper. I was looking at electronic cigarettes. I'm always looking for the next emerging contaminant. We're in a little bit of a dangerous situation right now, is because the whole environmental contaminant research, everyone that's doing and working in this area is pretty much focused on PFAS. It's like I'd say maybe, I don't know the numbers, I would say 70%, but I don't know for sure. But it seems like we're all focused on PFAS, and it's because that's where all our funding is. What about all the other chemicals? Are we missing that? So I am actually on the lookout already for what's the next emerging contaminant, and I have some ideas in my head what these compounds could be. And some of them that I've been interested in are the replacements for PFAS.
Wow, okay, interesting.
So I'm already positioning myself to
You're ahead of the curve.
trying to.
Yeah.
But that's really our job, especially in the analytical chemistry world, is our job is like an early warning system.
Yeah.
We start to pick these things up in the environment, and that's really what we've actually done our job with PFAS. We said, hey everybody, this stuff's really showing up everywhere. We need to stop it. I don't believe that a lot of these things we need to go back and remediate, because really what we find in the environment is really low level.
Okay.
It's usually part per trillion, part per billion at the best. And there's a lot of other contaminants that are there at much higher concentrations. We know that they're there, but nobody wants to fund that research. Nobody wants to talk about that because number one, they never figured out how to get rid of it.
So it's not even like it's not as hot of a topic. I guess.
Exactly, and the people aren't funding to look at PCBs, even though they're in your blood and they're at higher levels. But
interesting.
But where was I going for this? But yeah, I am looking for the replacement for a lot of the replacement compounds for PFAS because we have a tendency to fix one problem and just
create another one.
Yeah. And especially with chemicals, we tend to have a tendency to replace them with ones that are even worse than the first ones.
Interesting.
I mean, that's it's crazy, but it happens. It happened a lot with flame retardants.
Okay.
We used it in a lot of textiles that they took away one and put in a worse one. So.
And that's just to be able to say that, oh look, like we got rid of this harmful one, but
because it hasn't been vetted thoroughly.
Right. It's just the name changed, so therefore it's like
and that's what they do a lot of times with the chemical companies. Even it's happening with PFAS. Is PFOA has been banned, PFOS has been banned, but then they come out with 10 more, and they're usually just a slight change in the chemical structure, and then they have to regulate that one, and it has to take them years to regulate it. That's why when it comes to PFAS, what I've been saying for many years now is instead of chasing each individual one, we should just ban organic fluorine as a whole.
Yeah.
Like just say total organic fluorine. That's what we should be measuring. If it comes up with a high enough total organic fluorine, we should be.
What's the opposition to that? Like why?
I think it's a cost standpoint, right?
Well, first of all, what is it is a good question, and I bring it up all the time, and I don't know what it is because I guess people could say, well, there's types of organic fluorine out there that are not toxic.
Okay.
So you would be picking them up, or I don't know for sure, but I do get some pushback when I bring that up. So maybe also that people claim that there's not a good method to measure total organic fluorine, but that's one of the things I've been working on. So that's what I'm pushing it.
Interesting.
Yeah, because a lot of times, like our strictly based mission is essentially going back to what works, and that's how I like to choose like my own diet and things. Because I've seen a case study. I know my ancestors have been eating one ingredient foods for thousands of years, and now when you introduce these new compounds, now I'm not saying that this might give you cancer or this might kill you, but I don't know what it's going to do 50 years down the line, so I'll stick to what works. So that's our whole vision. That's why we're like pursuing our mission right now.
No, I actually read some of your stuff on your website, and you're building some kind of app that you can scan.
Yeah,
I thought that was cool, and that's a major player in the PFAS world because again, we can educate people and we can tell them move away from PFAS, don't use these materials, but the problem is they don't know which materials have PFAS. And I've been beating my chest that we need to do better jobs of labeling. But that would be a great thing is anything that has organic fluorine should be labeled and let people decide if they want to use it or not. And I bet you if they're educated, they'll move away.
Because I personally don't know what products are in the supermarket have PFAS in them.
And not even the manufacturers know. I've been looking at materials that aren't supposed to have any PFAS, but they're in there because even the company
using
using
from analyzing it too. Like you're not like looking at like what they're claiming. You're actually looking at the
taking it apart. Example is water purification systems, like this one. So I had taken one. I take several apart, and I'm not going to say the name because I have to be really careful here, of course, because this is somebody I'm partnering with. But we took one apart and we were analyzing all the parts for PFAS, and lo and behold, there was a couple of parts that did have them. And the parts that did have them were like, they were kind of like textile-like. It was woven polypropylene, that's what it was. And they didn't know it was there because I believe the reason why it got there is because they use PFAS as a friction reducer when they extrude the plastic. So it really wasn't an ingredient on the plastic, but it just got introduced during the manufacture. And here's the thing that really will drive you batshit crazy, is that it's not consistent in every device. Like you can analyze one device here and it's got some, you can analyze here, it's got a lot, and you can analyze one here and it doesn't have a lot, because when they're making that woven fiber that somebody's adding that PFAS at certain times to, you know what I mean, is the friction reducer.
Is that just like the manufacturing plant's fault?
Probably, I guess, but they might not even know. In fact, they might just be using friction reducer XYZ, and they don't even know. And in fact, there's a limit to the ingredients, right, where you have to report it.
Yeah.
So if it's a certain percent level, then they have to report it. But if it's below it, they don't. And who knows? And even that chemical manufacturer might not know. I mean, it's a whole supply chain.
There's so many components that come together just to make one thing. So.
Crazy.
Yeah.
And they come from all different countries where regulations are
of course.
different. I mean, it's
a mess.
If you looked at the underbelly of it, it's probably so complicated. You pull your hair out trying to track it down.
It's good business. Yeah. But yeah, so what we're kind of trying to do is exactly as you've been saying in terms of behavior change.
Mm-hmm.
We want to encourage, I mean, I don't want to say skepticism, like we're all going to get conspiratorial or whatever. But the idea is just like to kind of question what we're presented. And one of the main, I guess you could say our nemesis, our enemy, and our mission here is like foods that are presented as very healthy, right? So foods that have labels of something being diet friendly or keto or paleo, et cetera, et cetera, et cetera.
Yeah.
When it turns out they just have, something that's marked as 0 sugar, but there's a lot of sugar alcohols, or there's something that's packaged in some weird packaging or whatever it may be. And we just want to encourage people to, if they don't know, then check, right? And that's what we're doing for our app, is just peace of mind altogether. Just look at all the ingredients at once, and we'll tell you, like, don't even, like, and we'll give you like all of the information about it, but like you don't have to worry about like, I mean, to a lesser extent, I guess there's always, as you said, you never know what step.
That's true.
But at the very least, we want to encourage the habit of just verifying everything that you're going to be consuming.
Yeah.
So,
I like it.
Yeah.
I really like it. I hope you guys have success with it. I think it's good. Yeah, there's a lot of greenwashing out there.
Of course.
I mean, it's really a marketing ploy. Recycling is greenwashing in a sense. Plastic companies promoted recycling as the solution to the problem, when we really know it's not. California is actually suing them. But
California always. Yeah. It's always like, okay. That's another question I have about California specifically, because they have a lot of legislation around that stuff, but people argue as to like how much of it is actually useful. But my question for like recycling itself, on like a milk carton, for example, there's like a number 1 with like a recycling symbol around it, stuff like that. Mm-hmm. That isn't an actual recycling symbol, right? Like that's just about what type of plastic it is, or what is it about, like the type 1, type 2, type 3, or whatever?
It was supposed to make it so you could sort it better, right? Yeah, because you don't want polyethylene PET in your polypropylene stream. I think that was what was intended. Okay. But you know what? I'm not really well versed on where it came from. Okay. And
you're more looking at like where it ends up, right?
Yeah, I'm a chemist, so I'm interested in measuring these things, tracking them to the environment, developing ways to detect them. But I have heard a lot of stuff about it's a really useless. Yeah. I have read a couple articles, but I don't remember I can't remember exactly what they were saying.
Because out of my own curiosity too, I just looked into that something to do with like just organizing where it goes, but then ends up being somewhat misleading for the consumer who thinks they're getting something that's recyclable, that they can recycle, but they actually can't with like the way that they're doing it.
Exactly.
So in order to take care of some of these things, they have to take them to a specific like plant that can actually treat that specific plastic. Yeah. And it's really interesting how that plays out. Yeah. But then, so back to I guess California, and just in general, like in the United States, how effective is our legislation at actually like hopefully remediating some of these issues?
It's actually worked pretty well before in the past, and I'll give you a good example. In 2014, thanks to the Obama administration, we have something called the Microbeads Waters Free Act. And prior to that, we used to constantly find these perfectly little round microbeads everywhere in our waters. And they were coming from exfoliating creams, toothpastes, but now we don't see those anymore. We mostly see fibers and fragments. We don't see a lot of those perfectly. They still show up.
What are they? Like what?
They were put in cosmetics for like exfoliants. Okay. Or for like grit for your toothpaste.
Yeah.
Used a lot.
So something like a texturizer type of. Yeah. Like a mechanical exfoliant. They call it.
Exactly. Okay. And they still are. I can get into a whole talk about it. You should think about cosmetics.
Okay. Yeah, that's our next. Don't worry. Yeah,
finding some very interesting things. I got a project right now with cosmetics.
Trust me. Yeah, we're getting into
You can scan also any item with a label on it.
With the ingredients label. Cool. So, but soon we want to get even more specific on cosmetics, because that's anything that you're going to be consuming, putting in you or on you. Yeah. We want to make sure like there's some level of information you have. Yeah. But what you're saying is that with these mechanical exfoliants, they're plastic based or they're not?
They're plastic. They were polyethylene, vast majority of them.
Wow.
And they were showing up constantly, especially at wastewater treatment plants, because people were washing their face with it, they were washing their teeth, they're spitting it down, and it was going in the drain.
No way.
And ever since that law came into effect and they phased them out, though, it's pretty cool. We don't see them as much.
Okay.
I mean, the ones that are out there are still in the environment. They'll be there for decades to come.
But you're saying you saw the direct effect of that legislation?
Which is really cool.
Okay.
You rarely get to see that.
Yeah.
I'm fortunate and I'm blessed to
like
witness that
before and after,
in my lifetime.
Yeah.
So it did make me it gave me hope. Let's put it that way. That regulation.
Definitely.
Yeah. I mean, I know. I do a lot with clothing as well, so I know like with a lot of like acrylic materials or things like that, the microfibers that come out of those end up getting into the water or whatever other system.
Mm-hmm.
How can we reduce those? And what if you were to make legislation against something like that? Like, would you just ban acrylic altogether? Like, how is there?
Yeah,
how do we approach
I would
like
just
that?
jump right into banning acrylic, right?
Okay.
Because we would want to know we'd have to do like a life cycle type analysis. This is something I don't do.
Yeah.
But we need to find somebody that can map it all out. What is going to be the alternative? How's the alternative going to affect? You know, how's this going to affect? You know, like people that are economically, they can't afford. And what if the new material is more expensive? Then what do you say? You can't buy clothes. So we got to take into the populations that are at risk because of poverty and so on. So we just need to try to find a way to think about all these things and map them out. Get some really smart people.
Yeah.
Maybe you guys can.
Hopefully.
Yeah. And you know, as someone, clearly you're very well versed in the chemical field, and I just wanted to ask you on a personal level. Let's say me as an average person, I want to just improve my overall health and avoid as many chemicals as possible.
Or like harmful chemicals.
Yeah, harmful chemicals. So what lifestyle changes should I do in order to achieve that? What are some simple,
like actionable steps?
Well, I know these guys that are making this app.
Oh, I heard about that too.
Yeah, I mean, you just making educated choices about the things that you surround yourself with. I mean, but that's again, you need to know what's in the stuff that you're purchasing. But like, you know, the textiles you're putting in your home, the clothing that you're wearing. I think, you know, really giving some thought into that. You know, I live in the country. And I have a really interesting situation is I don't have garbage service.
Interesting.
So like everything I bring into my home, when I buy something, I ask myself, what am I going to do with this when I'm done with this? What am I going to do with this packaging? So like it really has changed the things that I bring in.
Yeah, your consumption is completely different.
Because when you have to go out every Saturday and sort your garbage, you know, one time I had to get rid of a couch that took me forever. I think I spent 8 hours breaking it down into every individual piece I could and tried to find, like I took the wood out and I burnt that and I tried to find the pieces that I could recycle and the metal. It really changes your how you consume.
You see the whole cycle,
Because right now people, it's really easy for them just to take out their garbage to the corner.
You don't think about it.
Yeah, and it's cheap. It's too cheap in my opinion. Landfills are making a killing, and I should be careful. And I think if people had to pay more money for their trash, they might start, especially if they had to pay for it on a per pound basis.
Yeah.
I mean, that would really...
I've seen that proposed a lot of places too, but it just never picks up anything. Yeah. I mean, shoot, I forgot. I lost my train of thought. What was I gonna say? Do you like so you don't have like a proper garbage system, then if you do like composting, like what usual
all food waste goes out to the field, the coyotes eat it, you know, everything that, you know, usually I try to buy things that I think that are going to have a chance to be recycled. You know, I think it takes me about 2 or 3 months to make a bag of garbage.
Wow.
Maybe like this, and that's mostly like styrofoam.
Interesting.
Because you really can't recycle that, and it's really, you know, a lot of rare things that I can't get rid of. Metal, aluminum, all that. I take it in. I get money for that. So.
Okay.
But it definitely changes the way you operate.
The way you purchase as well.
Of course, yeah.
And in terms of consumable products, do you like...
I avoid them all costs. In fact, yesterday I went to a pizza thing and the girl kept trying to hand me a plastic plate and I said, no, I'm going to eat it off this napkin. I mean, I am very conscientious about that. Like I have silverware. People make fun of me when I go to conferences, and that's the thing that makes me sick is when I go to conferences
And just see how disposable everything
and
is.
they don't even put any thought into
Yeah.
In fact, I once went to a conference about buying local, and they were handing out mugs, and I looked at the bottom and it said "Made in China." And it was like it's really important that when we do these things that we actually
being intentional.
And actually, show that we're making an effort and we really believe in what we're doing. But if you ask anybody that knows me, don't hand me a plastic straw, don't hand me a plastic bottle, I won't take it.
Yeah.
So,
conferences are definitely the worst. They're meant to just be up a day or two, then down, then the whole thing just gets thrown out. So I've set up some conferences before, some like conventions. The whole thing, like when people leave, there's just garbage everywhere. They literally bring in like whole like machine just to pick everything up and just throw it out. So yeah, it's insane.
it is crazy, especially when they're supposed to be about plastic pollution.
that one's funny. I actually never even thought about that.
Oh yeah, it's crazy.
Okay, interesting. Yeah.
And in terms of like self-care items, I know you're talking about a lot of
Personal care products.
Yeah.
Yeah.
Do you avoid, like, for example, I know a lot of people avoid toothpaste fluoride in it.
I don't avoid toothpaste. That is something that I will keep using.
You'll keep using it?
Yeah, there is options though. You can get toothpaste that doesn't come in plastic tube.
How does that work? So
I haven't seen it yet, but my colleague Ray McNash, who's in California, she does microplastics pollution stuff too, and she's told me that she found one. I gotta ask her to send it to me. I gotta look into that. But there's certain things I just can't avoid. Like a toothpaste thing. But I'll tell you what I do is I cut it open, I get all the toothpaste out of it, and then I try to recycle it. Because I think it doesn't even have a recycling.
I don't think so.
Oh, it doesn't?
I don't know.
I can't remember, but I thought I checked one time and I thought it was polyethylene. And the thing is I actually, my girlfriend, my wife goes crazy about it because I'll clean the crap out of all this stuff.
Yeah, because that's how you recycle it.
Yeah, I mean, she's like, why are you washing it? No, I want it to get clean so they'll recycle it.
Yeah.
Well, we have a friend, he's really into the space as well. He uses baking soda.
Yeah.
When he
That
brushes
would
his
work.
teeth.
Yeah.
And people did that for years. But it's important that you still, and I really, I'm curious, so why do you ask me about fluoride in toothpaste?
Because that's just another chemical that's like, that people point out a lot in terms of it having negative health outcomes.
See, I'm not educated on the fluoride thing, but I always thought it was okay to use. But with this whole change in administration,
It's a whole,
I haven't looked into that. I guess maybe I need to read it.
As far as I know, I mean, there's a lot of people that are like, that kind of make stuff up about it. All I know is that I just want to remove as much as I can that may harm me.
Yeah.
But there's people that say it causes some level of like calcification in certain areas of the brain. There's people that say that it has like, because it's like, I don't even know, it like can concentrate in your
hormonal
body.
glands as well.
Yeah, it can disrupt the endocrine stuff. I don't even know, to be honest.
Yeah.
I just try and whatever gets my teeth clean, and whatever's like minimum amount of ingredients, that's what I go.
It's a trade-off, though.
Yeah.
I mean, if you don't use it, what's your chances of getting dental problems, which is a health issue that might be worse than. It's an example. Perfect example is disinfecting water.
Mm-hmm.
We know that 1 in 10,000 people are going to get cancer from disinfectant byproducts.
Mm-hmm.
But if you don't do it, a lot more people are going to die from disease, from bacteria and pathogens.
Yeah.
So there's trade-offs there. There's lots of those. Flame retardants that are put in textiles, yes, they are endocrine disrupting. Yes, they get in the environment, but think about all the lives they save from fire prevention.
Yeah.
And DDT is another classic.
I was about to say that. We did a case study for that in class.
Yeah,
it's just you cause so much more disease than the actual harms of the pesticide.
Yeah.
So yeah, that's insane.
And the food.
Do you know about the DDT stuff?
No, I don't.
It's like in Africa they tried to roll out like a DDT prevention. So like they just kind of banned it. Like you can't use this pesticide on your crops anymore, right? And so the thing is, because of this, and it was supposed to what's it called? It was a pesticide that killed off. What did it kill? It was mosquitoes. I forgot. I did it.
Mosquitoes is definitely one.
So
they used to spray people with them, and they used to drive trucks around neighborhoods and spray it
with the DDT. Yeah. So it was the DDT. It killed off a lot of mosquitoes. So
malaria.
And so they banned DDT because they said, okay, it's too much harmful. It's too harmful. It's like toxic, right? But then so many more people ended up dying because of malaria because of the transfer from mosquitoes.
Yeah.
So it was really
and
interesting.
Food shortages too.
Yeah.
Because all that pesticide was used, more people can eat.
Yeah.
But then if you're not using it and the crops are not doing as well and being destroyed, then people will start starving. So it's those trade-offs.
Yeah.
I mean,
So you always find like not all innovation is bad, but also at the same time, a lot of innovation like plastics can sometimes not only harm the environment but also harm the body.
But they might just harm it later too. That's the thing. So right now, if you need a short-term solution, it's like you're gonna need to adopt some of these things, and that's why they stress a lot of like localized solutions. So like if there's something that like this community needs to, like the community itself needs to kind of make the decision of how we're gonna weigh out the short-term, long-term, the benefits, the negatives, stuff like that. It becomes a whole headache, man. It's like the more that I learn about it, it's just like it looks just more impossible to solve.
Yeah.
So in every generation just says, hey, the next one.
The next one.
Kick the can down.
Yeah. So overall we just gotta become more sustainable, more just in general, just change our behavior as society.
I think that's the big one.
Yeah.
And don't consume so much. Do we need to actually consume so much?
Yeah. And everything comes down just to a minimalist lifestyle.
Of course, yeah. Single ingredient foods, carnivore, whatever. Paleo,
Anyways, thank you for coming.
Oh no, this was great. I thoroughly enjoyed it.
For sure.
Thank you. Yeah. Would you guys be able to share this when you're done?
Yeah, definitely. We'll send you some links, and I what's it called? I would be opposed to having you on a second time just to get more detailed and more specific. This has been really great so far.
Sure. And actually, if you guys are ever in down, I'm in the South Research Park. If you ever want to see the laboratory, if you want to put the laboratory.
Do a lab tour. That'd be sick.
I can show you the equipment that we use and introduce you to the
Sure.
people.
That'd be great.
Awesome.
That'd be great.
All right, well, thank you very much.
Thank you so much.
Thank you.
Appreciate it.
Thank you so much. Thank you for your time.